Okay, now moving on to Coulomb's law. So what is it? Well, it's a way that we measure the force between two charges, or as we'll see soon, many charges. And this depends on the amount of charge we have and the distance between the two charges. So if you remember from Newton's third law, we know that the force 1 on 2 is going to be equal to the force 2 on 1, just equal magnitudes, opposite directions. This applies for our forces here as well, because they are vectors, and it's important to remember that these forces are vectors. Now the equation we use is k q1 q2 over r squared. What k is, it's Coulomb's constant, and it's just a set number. It has a magnitude of 8.897 times 10 to the 9 Newton meters squared per Coulomb squared. Usually though, when we're just doing regular problems, we're going to use 9 times 10 to the 9, just so it doesn't get too confusing. And our q, down here, these are measured in coulombs. Our r squared is measured in meters. So note, all of this is in SI units, meaning we have our newtons, we have our meters, and we have our coulombs. We have to be able to convert kilometers into meters or microcoulombs into coulombs in order for this to actually work. So now the unit of our force, just like in mechanics, is going to be newtons. So let's just look at a quick example. We have Q1 down here, charge 1, and we have Q2 down here, charge 2. I'm not telling you their magnitudes, but I am telling you that they're separated by a distance of 3 centimeters. So what you need to do is you need to write out your equation. And I'm asking you to find the force exerted by Q1 on Q2. So what effect does Q1 have on force on charge Q2? To figure that out, I'm going to draw from Q2, and I'm going to see how it's being affected. Now this is positive here, this is positive here, meaning there's a repulsive force between the two. So I'm going to draw my vector to the right. This is in the positive I hat direction. There are no components in the j hat direction for this example. Now, to figure out what the force is, I do k, Coulomb's constant, times the magnitude of Q1 in coulombs times the magnitude of Q2 in coulombs divided by r squared, so the distance squared. What I would like you to do is allocate absolutely random numbers to Q1 and Q2. They can be nanocoulombs, microcoulombs, just coulombs, and I want you to figure out what the electric force on Q2 is. Now I kind of mentioned before, but sometimes we don't only have two forces. We can have lots and lots of forces. So the forces exerted on one charge is going to be equal to the sum of the individual forces that are being exerted on it. This is called the superposition principle. So, again, really important, these are all vectors. So this is a vector sum, meaning you need to know the components of the vector in both the I hat and the j hat direction. So if we look at here, we can see that they're all along one line, meaning there are no j hat components, which is nice for us. I am asking you to find the force on Q1 by Q2 and negative Q3. Again, I'm just going to give you your distance, so I have 4.5 centimeters and I have 4 centimeters. What this force is going to look like is on Q1, I'm going to draw the force being exerted by Q2. Here we have a positive charge, and here we have a positive charge, meaning there's going to be a repulsive force. So the electric force is going to be going this way. I can see that in this image right here. Now I also have a negative charge here and a positive charge here, meaning there's going to be an attractive force. So I draw from Q1 all the way to Q3 because attractive. Now to find the total force, the total electric force, I'm going to have to add these two together. Now they're both going into the positive I hat direction, meaning I can just add both I hat components and I'm going to get my resulting electric force. Same thing as last time, I want you to write out some random numbers for your charges and then to try to solve the resulting electric force on Q1 by those two charges. The next video is just going to be about electric fields.